And this generation does not intend to founder in the backwash of the coming age of space. We mean to be a part of it. We mean to lead it. He said because it is there. Well, space is there.
When can I take off these stupid glasses? I've had them on forever now. I mean, how much longer could I possibly need them for? Wait a minute. No way. We aren't in totality right now. We are. Look at how dark it is in my room.
Bruh.
I mean, that's totality if I've ever seen it. Hello everyone, welcome to episode 4. And before we start this, let's get straight into our special segment today, the Eclipse Special. Now, a NASA jet was actually chasing the eclipse and got an actual look inside to what it was like. They traveled the entire totality path collecting data on the sun's corona. And here's going to be a closer look on the screen. I'll show you that. And also, not only that, but we had the Colorado jets. Not only what NASA was flying, but Colorado-based scientists were also chasing the solar eclipse, measuring the sun's corona, which will help us predict weather forecasts of the space storms. This was done by the National Center for Atmospheric Research. There is so much opportunity from this eclipse to learn that has raised, and scientists are wasting no time at all, as I think most of us have seen tons of jets out there studying. And also another jet, the Delta jet. There's actually an airplane that took people all the way through the path of totality. If you haven't heard about the pricey airplane ticket, sadly, the plane never got dark and they actually didn't get to see the eclipse at all. If they did, it was very tough from the angles. I mean, I guess the good part is a couple got engaged. I guess so. And there was millions. The eclipse path reached 115 miles wide and 10,000 miles long. And the number of people who live on that path were about 31 million, including me. I got to check it out, once in a lifetime experience. A solar eclipse is when the moon and the sun are perfect distance away that they almost mask each other. People quoted there being almost a tailgate atmosphere. Everyone is coming together to enjoy this beautiful moment. It really shows that we can come together despite how much hate we have for each other to enjoy something amazing like this. The next eclipse will be August 12th, 2026 in Iceland, Greenland, Atlantic Ocean, in Spain, and then North America on March 30th, 2033 in Alaska, and then finally August 23rd, 2044, Montana, South Dakota, North Dakota, and areas of Canada. Also one a year later than that, August 12th, 2045, we'll have a good amount of states, including California, Florida, Alabama, and more. And I'll put the one in Mexico in the description or whatever. And then we're going to take a look at these amazing photos we found all around the United States from people taking them. We'll have them posted on the screen as this rolls. But yeah, and let's get into the history of eclipse. The oldest recorded eclipse was around November 30th, 3340 BCE. This took place in Ireland and was found by petroglyphs depicting two circles overlapping. There was also remains of 50 burned individuals, which may have been an offering due to that ritual. And then in 1200 BCE, China, they started to record eclipses on almost anything, mostly animal bones, which they called oracle bones. They described it as the sun being eaten. After these were recorded, they were studied by NASA, and they were able to find exactly when these eclipses happened. They ended up finding the time and using past eclipses to find that the rotation of the Earth has slowed down, which could explain the variety and the time and the dates of these happening. Not to mention, but these appeared in a religious texts very often. These eclipses could be alluded to the Mayans, Christians, and almost all religions. Actually, in New Mexico, there's a petroglyph carved to represent July 11th, 1097 eclipse, and possibly a CME, which has been mentioned in a previous episode. Coronal mass ejections. Looking at the science side, Sir Arthur Eddington was able to validate Einstein's theory of relativity due to the bending of light during the eclipse. Not to mention that the most recent eclipse happened in 2017. This happened in about 38 states, and about 11 spacecrafts from NASA and more organizations studied it. The eclipse has a rich history of being prophetical, or whatever you want to call it, groundbreaking and just amazing. I hope everyone enjoyed the eclipse and had a life. Well, I mean, hopefully you weren't stuck in the clouds, because I know a few people did have those issues. But it was truly a magical moment. I'll show you pictures I had and everything, but once in a lifetime experience. And that's going to conclude our Eclipse Special. And oh wait, I actually think totality is about to end, so let me put these back on. And I'll see you guys in the actual episode.
Bruh.
Oh, finally, totality's over. I feel like it lasts forever. I didn't want to get beamed by that light. I mean, it was cool and all, but these sunglasses just aren't doing it. I mean, I guess it makes sense why my eyes hurt were like the top search today, but I think it would have been cooler without them. Oh. Sorry, I didn't see you guys there. I hope you guys enjoyed the solar eclipse segment I put together today. I had a lot of fun putting it together, learning all this stuff, and hopefully you guys learned something about maybe the history or even the jets that were flown during that time period. And without further ado, welcome to episode 4 of the Space Show. I'm your host as always, Nick. Thank you. We're going to be going over the dates, April 8th through April 10th, Wednesday, 2024. Without further ado, let's get straight into the news. Today, we have the close approach of Saturn and Mars, the conjunction of the Moon and Jupiter, and the conjunction of Saturn and Mars. Go check those out. And then tomorrow we have the close approach of the Moon and M45, which is the Messier Galaxy 45, and then Mercury is going to be at inferior solar conjunction, which is basically when it passes between the Sun and the Earth. And then launches, we have the video of the Delta IV Heavy NRL 70.
Rope ignition.
T minus 10, 9, 8, 7, 6, 5. We have ignition. 2, 1. And liftoff of the final United Launch Alliance Delta IV Heavy rocket, carrying NROL 70 for the National Reconnaissance Office and closing,
which I'll put on the screen. And then today we have the Falcon 9 Block 5 Starlink Group 6348, which is at 12:04 a.m. Eastern Time Zone. The Angara A5 test flight, which is going to be Wednesday today, 5 a.m. Eastern Time Zone. If you're up early, give that a watch. Then we have the Falcon 9 Block 5 USSF 62 WSF-M, which is going to be Thursday at 8 a.m. Eastern Time Zone. And then Friday, Falcon 9 Block 5 Starlink Group 6-49, and that's going to be Friday at 9 p.m. That's a good one to watch, not too early. First news of the week, the military co-op. This week, the United States and Japan will be meeting to modernize their military alliance. Will be announcing their first non-American on NASA mission to the moon, which will be very exciting. This will actually be taking place, well, today. This treaty will go over the international commitment to not deploy any nukes in outer space, surprisingly. This is being discussed by the UN, as Russia is heard to have been making some nuclear-capable anti-satellite weapons. This treaty is in place, and the US and Russia have been iffy on it. The most well-known nuclear test in low orbit was the Starfish Prime. The way that the bomb interacted with the atmosphere and magnetosphere of the Earth caused an EMP, which was because it caused a burst of gamma radiation, and then the rays interacted with the atmosphere and the molecules, those ionized, and made a plasma cloud. This plasma cloud expanded and causes so many power outages in Hawaii, in the power grids and everything. Since it was in space, there was no air to absorb the rays, which allowed it to go faster and be stronger. While there seems to be no military value to nukes in space, it could end up damaging satellites if it occurred, which is why making this treaty continue is important. And let's get into the next one. Hubble looks at interacting galaxies. This image that Hubble took contains the galaxy NGC 5996 and NGC 5994. These galaxies are about 67,000 light years away from each other, and when talking about space-time, that's not that far. And the core of NGC 5996 is about the same size as the Milky Way galaxy, well, the galaxy in total. One can see how the tidal tail makes the galaxy larger, which most likely happened from the two interacting as they pull on each other. And then NASA's LRO. NASA's Lunar Renaissance Orbiter has been studying the moon for the last 15 years and actually caught some pictures of Korea's Danuri Danuri Lunar Orbiter. Due to the velocities, extreme precision was needed to even see this thing. The shutter rate on the LRO was 0.338 milliseconds. It was only able to catch only a glimpse of it. Just think how fast that is. What a very cool discovery on such a big moon, considering these orbits are traveling pretty much parallel at such high speeds. Very cool picture. I'll put that on the screen. It looks like a smear. And drilling. Drilling. I mean, simple on Earth, right? But when we get into drilling celestial bodies, we seem to have issues. Celestial bodies hold a lot of valuable resources, which make it inevitable to mine them, but how? Most of these bodies don't have atmospheres, which could make the drill melt. They usually would use cooling liquid, but with no atmosphere, it's not possible to use it. It would simulate right away as it was used. There are also issues with clingy regolith ruining the drill and getting stuck on it. Also, the power, or lack of it, is tough because we'll be able to find solutions to mining those asteroids that have specific dates when they're in range. Will the power last that long, though, for us to be able to reach the asteroid? We still have a lot to research with mining. And wobbling stars. First off, magnetars are defined as neutron stars with a very strong magnetic field. Neutron stars are just high-density celestial objects that are made of closely packed neutrons. If the massive star is not big enough to produce a black hole, then neutron star is the next best option. Basically, when a massive star runs out of fuel and collapses, the core ends up collapsing and crushing together protons and electrons into neutrons. I can't really explain that process without a lot of vocab, but I get more into this, but maybe for future spotlight. But a research team led by Georgi Devinge from Max Planck Institute for Radio Astronomy observed the magnetar of XTE J1810197. Magnetars are known to emit radio waves, and they finally caught it doing so. Imagine you have a spinning top that's a giant star, right? Now, this magnetar is not always perfectly balanced. It wobbles as it spins. Now, imagine you are far away from this toy with a special pair of glasses, like these ones, so you can see the radio waves being emitted. Scientists noticed that the magnetar's radio waves were changing in an organized way. The direction these waves were vibrating, which is polarization, was shifting. The wobbling didn't last long, but it was key to understanding radio bursts, called fast radio bursts, which are basically flashes of radio waves that release high energy. The organized pattern on this was a breakthrough for scientists, and it'll help them better understand these magnetars and neutron stars and much more. Hopefully you guys understood that. I tried to make it as easy as possible. And on to the next one, hydroplasma. Recently, more radio observations found a cloud of magnetized plasma in the Hydra galaxy cluster. This is actually a brand new object, and it's not even been seen before. It's unclassified, but it's called the Flying Fox. I will keep you updated on the findings of these weird objects of plasma clouds, the Flying Fox. Very interesting. Now, gravitational wave. Researchers from the Institute of Cosmology and Gravitation have detected a gravitational wave signal. Now, analogy, think of a calm pond. When a stone is dropped into it, that creates ripples in directions, all directions, right? Well, when massive objects like black holes or neutron stars move or collide, they create ripples in the fabric of space-time called G-waves, or gravitational waves. It's important to understanding our universe and studying those events. Basically, they were able to detect a wave which they named GW230529, long name, which could have originated from the collision of a neutron star and an object 2.5 to 4.5 times the mass of our sun. Basically, this discovery helps us understand the mass gap. Imagine we are sorting objects by weight. So we have the lightweight objects and we have the heavyweight objects. But there's an empty zone between these objects, and we don't know what objects should belong there. And those objects could be neutron stars that are on the lighter end of the scale and black holes on the heavier end. And the mass gap lies in asking if maybe there's heavy neutron stars or light black holes. This wave found that the collision objects could fall within this gap. though it's only one study, this will help us learn more about those objects. Very interesting discovery. I'll let you know if I find anything more. And Cepheids. Astronomers at the University of Warsaw have just discovered a new classical Cepheid in our galaxy. Cepheids are kind of like a flickering light bulb. Cepheids are types of stars that change in brightness over time due to them expanding and contracting. It does that because it's somewhat of a tug-of-war going on between the gravity, which is pulling everything inward, and the pressure from the hot gases inside push it outward. Those times when it changes brightness are when one of those variables versus the pressure and the gravity wins. A newly discovered Cepheid, Ogle GD CEP 1884, which is the youngest one ever found, the longest period of contraction and expansion was recorded at 78 days, yet from our sky we see it flickering. This is pretty groundbreaking and it'll help us understand how stars evolve over time. Very cool. If you see a flickering star, that's a Cepheid. And mysteries of moon geology. Now, we all have a basic understanding that the moon was formed due to a smaller planet smashing into the young Earth, then solidifying, and then so how. It was believed that when the moon formed, it was covered in a giant magma ocean. And when it cooled down, materials like ilmenite, however you pronounce that, sank into the moon's interior, and then as those materials mixed with the mantle, it ultimately led to them falling back up in volcanic flows. Scientists recently used gravity measurements from NASA's GRAIL, which is Gravity Recovery and Interior Laboratory Mission, to basically study the moon's gravity in detail. Scientists recently confirmed that the magma ocean theory, as they found the moon's gravity field matches what they thought a layer of dense material beneath the surface would be like. They could confirm it. This helped us learn more about the moon and how it's basically almost lopsided on one side due to the mantle overturn, which has made it almost turn itself inside out. And also due to one side being more concentrated in the volcanic flows than the other. So those sides are pretty lopsided. Very, very cool. And encryption. Right now, we use encryption to send messages safely without hackers being able to grab it. Now, basically, encryption scrambles data into gibberish, which can only be unscrambled by special keys that both the sender and receiver have. Yet, super powerful quantum computers could end up cracking these someday, just because of the sheer force and speed of them. One way we plan to combat that is quantum cryptography. And what is that? It's using random properties of quantum mechanics. One idea suggested involves using particles of light, photons, to transmit data through satellites. Those photons make it almost impossible for hackers to intercept without detection. And if they get detected, they can just alter the photon characteristics so they can't reach the message. However, there is a limit due to the distance, since light does scatter as it goes out. But by using satellites, we can do this without any issues. Scientists are working on the Quick 3, which aims to try this out with satellites and try it out in 2025. So be on the lookout for the Quick 3 mission. And then Jupiter. What about Jupiter? Astronomers just found reports of a new and young warm exoplanet orbiting a near star, deemed TOI 4862b. Is similar in size and mass to Jupiter. It was discovered by the Transiting Exoplanet Survey satellite, which was a satellite launched by NASA to look for dips in brightness in stars, which will tell them if planets pass in front of them. It takes TOI 4862b about 98.3 days to orbit a star. Moderately eccentric in its orbit, which means it's stretched out in its orbit. It's not perfectly circle. And it's less than half the distance from the Earth and Sun away, which is AU. It's basically telling us, compared to the Earth and the Sun, how far is going to be AU units, and it's about 0.41. And this is a very interesting discovery. Very, very interesting. Am I right? And now that is going to conclude the fourth episode. I mean, we have the solar eclipse segment. We have lots of interesting news, foreign concepts, and nukes. I guess nukes. But I hope you guys enjoyed this episode. And of course, make sure to like and subscribe if you'd like to for New Space News. Of course, I'll be uploading Monday, Wednesdays, and Fridays. So hit that like button and hit the bell if you like. And hopefully this solar eclipse is done with, because I just want to look up at the sun again. I mean, wouldn't you? Remember, guys, as always, be bold, be original, be invincible.